Hello, good day everyone. This is Group 7 video presentation. This topic is titled Mathematical Modeling Technique of Linear Optimization with a theme of describing a linear programming problem. And these are group objectives. Linear programming helps students critical thinking, especially when they have their own business in the future. It provides better insight into business problems. Students can select the best solutions with the help of LP by evaluating the cost and profit of various alternatives. For many issues involving resource optimization, linear programming is helpful. To determine how to allocate labor and equipment to reduce operational costs, it could be used in production. Linear programming uses a mathematical or graphical technique to find the optimal way to use a limited resource. And last one, students must analyze a subject into its component parts and arrange the parts in sequential learning order. In the real world, the problem is to find the maximum profit for a certain productions using linear programming. Before we begin or continue with the introductions, I will first show you the content or conceptual framework within this video. Introductions. When faced with highly complicated practical issues, linear programming can be seen as an important aspect of a great revolutionary development that has given mankind the ability to articulate broad goals and outline a route of specific decisions to make in order to best attain those goals. We use models, algorithms, and engines to develop and solve models, which are the approaches to express real-world issues in precise mathematical terms, which is computers and softwares. That's all. Thank you.
Linear inequalities are expressions where any two values are compared by the inequality symbol. The inequality is a mathematical statement that shows the relation between two expressions using the inequality symbol. The following are the properties of inequalities. The first, the addition properties of inequalities. The second, multiplication properties of inequalities. The third, trichotomy property. The fourth is transitive property. The addition properties of inequalities state that adding the same constant of both sides of inequalities are equivalent to each other. The multiplication of properties of inequalities, if a positive constant number is multiplied by the both sides of inequality and the inequality remains the same. The trichotomy property means that when you are comparing two numbers, it's either less than, greater than, or equal. Transitive properties, the relation between the three numbers is defined using the transitive property.
And now, let me show you some of the examples of properties of inequalities. Let's have first the addition of property of inequality. In this example, adding both sides by 2 and then simplify, the answer is 12 is still greater than 7. The inequality remains the same. Second is the multiplication property of inequality. So in this example, multiplying 5 in both sides, the answer is x is still greater than 30. The sense of inequality did not change. Third is the trichotomy property. For example, 4 and 7. Let's substitute this into our inequality sentence. Only one here is true, and that is 4 is less than 7. And lastly is transitive property of inequality. For example, let's take numbers 3, 4, and 5 on the number line. If 3 is less than 4 and then 4 is less than 5, then we could say that 3 is less than 5. Linear programming is the process of maximizing or minimizing the linear functions under linear inequality constraints. And now, let's move on to hyperplane and half space. A hyperplane is a geometric object with one fewer dimensions than its surrounding space. It is a border of a half space that it corresponds to. And a half space is a space that is identical to a hyperplane, but only extends on one side of it. And now let's talk about polyhedron. A polyhedron is a three-dimensional solid made up of polygons. It has flat faces, straight edges, and vertices. Polyhedrons are classified as prisms, pyramids, and platonic solids. For example, triangular prism, square prism, rectangular pyramid, square pyramid, and cube are polyhedron.
First, let's talk about convex set. A convex set is a collection of points in which the line xy connecting any two points xy in the set lies completely within the set. This is an example of convex set. Now, let's talk about linear programming problem. It's a problem that is concerned with finding the optimal value of the given linear function. For example, objective function, minimize c sub 1 x sub 1 plus c sub 2 x sub 2. Constraints, a sub 11 x sub 1 plus a sub 12 x sub 2 less than or equal to b sub 1. A sub 21 x sub 1 plus a sub 22 x sub 2 less than or equal to b sub 2. A sub 31 x sub 1 plus a sub 32 x sub 2 less than or equal to b sub 3. X sub 1 greater than or equal to 0. x sub 2 greater than or equal to 0. Now, let's talk about fundamental theorem of linear programming problem. States that every feasible linear program that is bounded below has an optimal solution in a zero-dimensional face, a vertex, of the feasible polyhedron. The following are the fundamental theorems. First, if a solution exists to a bounded linear programming problem, then it occurs at one of the corner points. 2. If a feasible region is unbounded, then a maximum value of the objective function does not exist. 3. If a feasible region is unbounded, and the objective function has only positive coefficients, then a maximum value exists. Lastly, let's talk about solving a linear programming problem graphically. It's used to solve problems by finding the highest or lowest point of the intersection between the objective function line and feasible region on a graph. There are 7 ways to solve a linear programming problem graphically. Number 1, define the variable to be optimized. The question asked is a good indicator as to what this will be. Number 2, write the objective function in words, then convert to mathematical equation. Number 3, write the constraints in words, then convert to mathematical inequalities. Number 4, graph the constraints as equations. Number 5, shade feasible regions by taking into account the inequality sign and its direction if A, a vertical line, B, a horizontal line, and C, a line with a non-zero defined slope. Number 6, identify the corner points by solving system of linear equation whose intersection represents a corner point. Number 7, test all corner points in the objective function. The winning point is the point that optimizes the objective function. Biggest if not maximizing, smallest if minimizing. That will be all.
Talking about solving the linear programming problem using simplex method. So first, we should have to know what is simplex method. It is an approach to solving linear programming models by hand using slack variables, tableaus, and pivot variables as a means to finding the optimal solution of an optimization problem. Simplex tableaus is used to perform row operations on the linear programming models as well as for checking optimality. So we have here example 1. Consider the following standard maximum type linear programming problem. Maximize subject to p equals 3x plus 4, objective function x plus 3y less than or equal to 30. First constraint, 2x plus y less than or equal to 20. Second constraint, x is greater than or equal to 0 and y is greater than or equal to 0. Using the simplex method, the steps are as follows. So we have here step 1, insert slack variables. Insert a slack variables sk into each of the structural constraints. The result is a system of slack equations. X plus 3y plus s1 equals 30, first slack equation. 2x plus y plus s2 equals 20, second slack equation. And we have step 2, rewrite the objective function. Rewrite the objective function to match the format of the slack equations and add the corresponding equation to the bottom of the slack equations. X plus 3y plus s1 equals 30, 2x plus y plus s2 equals 20, negative 3 times negative 4y plus p equals 0, and we have the step 3, write the initial simplex tableaus. The augmented matrix is called the initial simplex tableaus. Each number in the bottom row to the left of the vertical bar is called an indicator.
Step 4. Find the pivot element. The most negative indicator in the last row of table determines the pivot element. We apply the smallest quotient rule for that column. The pivot element is the most negative indicator in the third row. In this example, the second column is the pivot column with negative 4 as the most negative indicator. Step 5. Perform the pivot operation. Perform the pivot operation to find the pivot element. After the pivot operation has been completed, write down the basic feasible solution. The pivot element is equal to 3 corresponding to the lowest ratio equals 10. When you divide a constant column with values in the pivot column, turn the pivot element into the other values in the pivot column into 0 by applying possible operation to obtain it. Step 6. Check if there are still negative values in the third row. If a negative indicator is still present, repeat steps 4 and 5. If no negative indicators are present, the maximum of the objective function has been reached. The next pivot column is the first column where the most negative indicator is found again in the third row. The pivot element is 5 over 3. Turn into 5 over 3 into 1 and the other values into 0. We have to repeat steps 4 and 5 since we still have negative indicator in the third row. Since the third row has no negative values anymore, then we can say that the process is all done. Treat all the values under the slack variables as 0. Then the solution to our linear programming problem is p reaches a maximum value of 50, so p equals 50 for x equals 6 and y equals 8. That's all. Thank you.